Okay, for the train straight track, you'll notice I've created a new file, and I've brought in 3 pieces of track. You can bring in 3 or 4. You can always add more later. First thing, we're going to bring those in and constrain them, and then there are a few special offsets that we will need to reference. So putting those together, of course, we could do aligned inserts. Okay, that helps a little bit, but you'll notice that if I grab those other pieces, they still rotate. So that's simple enough. We just have to then flush the sides. Okay, then bring in your subassembly. And when you have a complicated assembly, this is what you would want to do. Of course, we go back to the wheel file. We may want to turn off the visibility on those work axes and work planes. Otherwise, that's going to show up in the file. Okay. Now, the next constraint we want to do, we want to do a 0.4375 offset from the top of the track to the bottom of the train body. Okay, again, that's a 0.4375 offset mate, top of the bottom, top of the track to the bottom of the train. And then there's a 0.7 offset flush from the track side to the side of the train body. Once in a while, the offset puts it kind of in the wrong direction. If that happens, your selection arrow is just in the wrong way. Sometimes you just put a negative in and it'll flush it up. So now this offset will be 0.7, and that's the side of the train to side of the track. Okay, so now if we zoom in and look at it from a head-on view, we will notice that the train is centered and the wheels are tangent to the slot on the track. The next thing is a motion constraint. Under motion, we're going to select this one here, which is translation rotation. And when we select that, we want to make sure we get a rotation axis on the wheel. So I'm basically just selecting the wheel. And then you also notice that we need a edge vector. So I want to point at an edge of the track, and you'll see, you know, when I make a selection, there is a little arrowhead. So I want to make sure I have an edge vector. So there's my rotation. There's my vector direction. Now, how far will the wheel spin with one rotation? Well, the wheel will spin the circumference of the wheel with one rotation. Of course, that's pi times diameter, which in this case would be 3.14 times 2.25, the diameter of the wheel. So under here, where I have the distance, that's where I need to put that, 3.14 times 2.25. Okay, and now the wheels should be rolling, but they're not. When you have a subassembly, you need to make it either adaptive or flexible. So on my train, I'm going to right click, and for some reason I do not have adaptive as an option, but I do have flexible as an option. So now that I made that flexible, you notice that my subassembly added some icons in front of it there. And now when I grab my train, my wheels roll. Okay? If your wheels are, for some reason, doing the moonwalk, which sometimes happens, your selection arrows are not in the right order. So what you could do, if you find that translation rotation and it's doing the moonwalk, the simplest thing to do is to make it a negative. Mine's going the right way, so I'm not going to do that. The last constraint to get it to drive is we're going to put a flush constraint with the back of the train and the back of the track. Now when you do that, that's going to show up in your browser under your train subassembly, and I want you to go find that and double click and name that drive. That way you can find this constraint later when you want to show off the motion. So now I have that constraint, and when I right click on drive, I'm going to do drive constraint. Let me cancel that for a minute. Okay, I'm going to right click on that and do drive constraint. And this is starting at 0 inches. That's the flush that we're driving. And it would end at 10 inches. Now I have 3 pieces of track. The train is about 5.5, 6.5 inches long. So if I go 30 inches, it's going to travel the length of the track that I have in front of me and not run off the track. If I open up this more option here, right here, this 1.0 inches, that's the speed that it's going to travel at. And somewhere between 0.1 and 0.25 is a good speed for most computers. This is going to tax your video card and your processor speed. If I do start and start, that's what I like to do because it'll roll down the track and then roll backwards. And here this will control how many times it's going to travel. So I'm going to make it 6. And then I could go ahead and press play, and you'll see there's my train rolling down the track. If I want to speed it up, I change to 1/4 inch, and now it's rolling a little bit faster. Okay, again, so everything I set up there, about 30 inches. If you put in 4 pieces of track, you could go 42 inches. Open up this more button, change it to about 1/10 to 1/4 inch for the steps, and then how many times do you want it to travel. And you'll notice mine is not real smooth. There's a little glitch in places, so that 1/4 inch is about as fast as mine's going to go. Okay, so that's the straight line motion. There's also a PDF document for circular motion. At this point there's no videos for that. We'll see if I get ambitious.